Hello everyone, I'm Shine and you are watching Civil Engineering Tips channel. In today's video, we're going to discuss about the internal reinforcement of shear wall. Maybe you are being surprised that why we're discussing about reinforcement before we're designing it. To make you understand easily, I'm just showing you the reinforcement pattern that are being used inside the shear wall. If you really know the conventional construction process of shear wall, then it will be easy for you to understand the design process of shear wall in ETABS. In this figure, we can see that this is on kind of core shear wall that is constructed around the lift, and in this type of shear wall we have three type of reinforcement, that is longitudinal reinforcement, shear reinforcement and boundary element. In the four corners we have four boundary element, and the reinforcement pattern is also different. We have vertical reinforcement and transverse reinforcement, and the reinforcement varies according to the location inside the shear wall. There is a tiny message from BNBC 2020, and that is vertical reinforcement need not to be enclosed by lateral ties if vertical reinforcement area is not greater than 0.01 times gross concrete area, or where vertical reinforcement is not required as compression reinforcement. So if the rebar percentage is greater than or equal to 1%, then we have to bind the vertical rebars by ties, and if the vertical rebar percentage is less than 1%, then we don't need any kind of ties to bind those vertical rebars. Shear wall is the combination of pier and spandrel. The reinforcement we already discussed was about pier reinforcement, but there can be spandrel, which is the horizontal portion in the shear wall. Rebar placement of pier and spandrel is different. There is another kind of special reinforcement which is called diagonal reinforcement inside the coupling beam of spandrel. We can provide coupling beam inside shear wall by two methods. This is method 1. You can see the reinforcement pattern of spandrel, and this is the method 2, and here we can see the reinforcement pattern of spandrel also. In this figure, we can see that the spandrel inside the shear wall can be constructed in two different ways. The first figure shows it is the conventional process of constructing a coupling beam in spandrel, and the second figure shows that there is a diagonal reinforcement available inside the spandrel. So here we are differentiating two methods of constructing a spandrel inside the shear wall. For coupling beams having L by H ratio greater than 4, it is designed as conventionally reinforced coupling beam using traditional longitudinal and transverse reinforcement. For coupling beams having L by H less than 2, it is designed as diagonally reinforced coupling beam using reinforcement with two intersecting groups diagonally placed rebars symmetrically about mid-span. These beams are easy to construct compared to diagonally reinforced coupling beam because the reinforcement pattern is very simple. There are only a longitudinal reinforcement and transverse reinforcement, and for diagonally reinforced coupling beam, these beams are not easy to construct. It is little bit complicated. In this figure, we can see that constructing diagonally reinforced concrete coupling beam is not easy. It is very hard to construct, and it is the traditional method to construct the shear wall. During seismic event due to reversal of moment, the flexural cracks at boundaries interconnect and sliding shear failure takes place. We can see the failure inside the spandrel in the first figure. The shear and moment capacities are entirely provided by the diagonal reinforcement, and the failure type in the diagonally reinforced coupling beam is shown in the right figure.